Start. Action.
Huwag ka muna magpapakamatay!
Muna?
Sasali ako!
Alam nyo? Hindi. Hindi.
Wala.
Kahit may mga regalo tayong hindi natanggap nung Pasko o sa mga espesyal na araw, magpasalamat pa rin tayo dahil sa importante, binibigyan tayo ng Panginoon ng pagkakataon na maninirahan dito sa mundo. Kung may pinagdaanan ka, palaging inilagay sa iyong isip na sinasabi ni Isaiah chapter 41 verse 10. So do not fear, for I am with you. Do not be dismayed, for I am your God. I will strengthen you and help you. I will uphold you with my righteous right.
Amen!
Mga
In mathematics, a limit is the value that a function or sequence approaches as the input or index approaches some value. Limits are essential to calculus and mathematical analysis in general, and are used to define continuity, derivatives, and integrals.
Calculus is said to be difficult, especially for those people who are just judging the length of its solutions. Oh, and also add symbols and numbers. However, it can be that calculus is hard because of lack in mastery with the basics. Well, according to Russell 2020, calculus is a branch of mathematics that involves the study rates of change. It is used in a multitude of fields that you would not ordinarily think would make use of its concepts. Among them are physics, engineering, economics, statistics, and medicine. This concept of derivative is that we have a slope, and with that slope, it is like, how can a second line become a tangent line? We have a second line and tangent line. The second line is a straight line which interacts 2 points on a function. So this second line is the average of change. A tangent line interacts only with 1 point on a function.
On to the second rule, derivative of a power function or power rule. Means, if a function is defined by f of x is equals to x raised to the power of n, where n is any non-zero constant and x is not equal to 0 for any given n, then the derivative of f of x is given by f prime of x is equals to nx raised to the power of n minus 1. For example, we have f of x is equals to x raised to the power of 5. We're just going to multiply the exponent to our coefficient or variable, and also have to subtract 1 to our exponent. So we have f prime of x is equals to 5x raised to the power of 5 minus 1, and subtract the exponent, so we have our final answer, which is the f prime of x is equals to 5x raised to the power of 4. Let's have another example. F of x is equals to x raised to the power of negative 5. Oh no, negative power. There's nothing to worry about. Same process. Exponent multiply and exponent subtract. So we'll have negative 5x raised to the power of negative 5 minus 1, and it will become negative 5x raised to the power of negative 6, and that is our final answer. We'll have our last example. We have x raised to the power of 6. You know the drill, multiply and subtract. So we'll have 6x raised to the power of 6 minus 1, and it will become 6x raised to the power of 5, and that is our final answer. Next rule is the derivative of a constant multiplied to a function, or also called as constant multiple rule, which means if c is a constant, then the derivative of a quantity of c multiplied by f of x is equal to c times the derivative of f of x. For example, we have f of x is equals to 2x cubed. We have to find the derivative of 2x cubed, so it will become f prime of x is equals the derivative of 2x cubed. Next step is it will become f prime of x is equals to 2 times the derivative of x cubed, because 2 is constant. It is like the rule number 2. We'll have to multiply the exponent to the coefficient and subtract 1 to the exponent, so it will become 2 times 3x raised to the power of 3 minus 1. Multiply and subtract. Then our final answer is f prime of x is equals to 6x squared. We'll have another example. We have f of x is equals to 20x raised to the power of 8. Same process, multiply exponent to that coefficient, so it will become 160x. Then subtract 1 to the exponent, so it will become 7. So simply, our final answer is 160x raised to the power of 7. We'll have our last example for today's rule. We have 2x raised to the power of 11. Same drill, multiply and subtract. So we have 22x raised to the power of 10. Let's jump off with the first rule, derivative of a constant, which simply means if a function is defined by f of x is equals to c, where c is any constant, then the derivative is given by f prime of x is equals to 0. In other words, the derivative of a constant is 0. Let's have our first example. So we have f of x is equals to 5. The next step is to get the derivative of 5. So we have f prime of x is equals to derivative of 5. Since 5 is constant, so the answer is f prime of x is equals to 0. We have another example. F of x is equals to 240 plus 16. Same process, we have to get the derivatives of each term. So we have f prime of x is equals to derivatives of 240 plus the derivative of 16. Since they're all constant, so it will become 0 plus 0. Our final answer is f prime of x is equals to 0. Let me get another example. We have f of x is equals to 164 plus 3 plus 952 plus 427 plus 90 plus 34. Sounds stressful, right? No need to be stressed. Just simply get their derivatives of constant because they're all constant. So they will become all zeros, and our final answer is f prime of x is equals to 0.
Hello, and welcome to Applications of Derivatives. There will be 3 examples that we will cover today, which is 1 from related rates and 2 from optimization. Applications of the derivative identifies concepts that are used in everyday life, such as determining concavity, curve sketching, and optimization, according to Brightstorm. There are several ways to expand this, but for now, let's focus with optimization and related rates. The two next examples are going to be optimization. Number 2. A rich lady with 975 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens. What is the largest total area of the 4 pens? To be able to answer this, it is best to illustrate it. So, we draw a rectangle. Then since it says to divide it into 4 pens, we will have it divided inside the area, which results to p is equals to 2x plus 5y. Our objective here is to get the x, but first, put negative 5 on both sides. And on the other side, it turns into 0 since negative 5 and positive 5 is 0. Then we divide 2x with 2. Using the golden rule of what is being done to the other must be done to the rest. So 975 divided by 2 and 5y divided by 2, we get a 487.5 minus 2.5y afterwards, which is the value of x. We stop here and proceed to the product, which is written as area is equals to xy. Then, the variables will be changed, and for some reason, variable x disappears, which is then the quantity of 487.5 minus 2.5y times y, and is distributed, then we have 487.5y minus 2.5y squared. After this, we take the derivative of it, which is 487.5 minus 2 times 2.5y, which is equals to 5y. So this becomes 487.5 minus 5y equals 0. Then add positive 5y to both sides, which is 0 to the other, and then remove the coefficient from y. That's why we divide 5 from it and apply golden rule to the other side. We have the value of y, which is 97.5 feet. To get the value of x, simply substitute it with 487.5 minus 2.5y. That is, x equals 243.75 feet. And we are not done yet. After this, we have to apply the formula of the area, which is made of x times y. And to put it to our problem, we have 97.5 feet multiplied to 243.75 feet results to 23,765.63 squared foot. The largest total area of the 4 pens is 23,756.63 squared foot. Which is to find two positive real numbers whose difference is 100 and whose product is a minimum. Since the way to solve this is the same as above, simply express this into x minus y equals 100. Then transfer this, which becomes x minus 100 is equals to y. Again, in the same way, we got the quantity of x minus 100 times x. Distribute, then we'll have x squared minus 100x. Form it into a derivative, which is 2x minus 100. We separate 2x and 100 by adding negative 2 to both sides, which leaves only negative 100, and on the other is negative 2. To eliminate the coefficient and leave the variable x, we divide negative 2x with negative 2, so as the other side. Then the value of our x is 50. Apply the formula to the other side, which is y is equals to 100 minus x. Then substitute variable x with 50, which therefore, the two real numbers whose difference is 100 and whose product is a minimum is 50.
Uy, Julian, channel guard. Bakit mo na-offer na yung pagsukin mo ako? Hindi ko na lang yan nakikita na tutulong sa klase. Ano kaya mo? Oo nga. Lagi yung bukid.
See?